2-6 Combination of Functions, Composite Functions, Day 2. Our learning goal is that you will be able to build functions that model relationships between quantities from existing functions. In this lesson, we're going to look at the algebra of functions. So we're going to be taking the functions and adding, subtracting, multiplying, and dividing. So these are the 4 operations that we can use to combine functions. And just to let you know, when you see, when they have you to do addition, it can either look like this, which means you're going to take f of x and you're going to add g of x. So you're going to be combining like terms if you can. Subtraction is similar. So you're going to take f of x and subtract g of x, combining like terms if you can. Multiplication or product. You're going to be taking f of x and multiplying it by g of x, which will either require you distributing or foiling. And division. You're going to take f of x and divide it by g of x. And we know that g of x can't be 0. And usually this is where you may have to factor to actually divide them. These two, you're combining like terms. Combining. And again, multiplication, you're either going to FOIL or distribute. So for the first example, we're going to find each of the following and determine the domain. So they're going to give you 2 functions, like here. And first, we're going to add them. So I'm going to take f of x, which is 2x minus 1. And I'm going to add it to g of x, which is x squared plus x minus 2. So since we're just combining like terms, I always start with my highest power. X squared. I have a 2x and an x, so that makes it 3x. And then negative 1 plus negative 2 is negative 3. Now, they're going to ask you to find the domain, and you do the same. And you figure out, do you see addition or do you see square rooting? If you don't see either, then your domain is still negative infinity to positive infinity. Okay. Subtraction is similar. So you're going to take 2x minus 1. And now we're going to subtract x squared plus x minus 2. So be careful with this negative. So that's going to give us negative x squared. Now we have 2x minus x, which is 1x. Negative 1 minus negative 2 is positive 1. And then our domain is still negative infinity to positive infinity. Multiplication. I'm going to take 2x minus 1, and I'm going to multiply it by x squared plus x minus 2. So basically, I'm going to be distributing each term. So I have 2x squared, or 2x cubed. You write it underneath it. Then I'm going to do the 2x times the x, 2x squared. And then the 2x times negative 2, which is negative 4x. And then I'll do negative 1 times everything, so that'll be negative x squared, negative x, and positive 2. And then you just combine like terms. Okay, and your domain is still the same. Our last operation for example 1 is division. So I'm going to take 2x minus 1, because that's f of x, divided by x squared plus x minus 2. So here, in order to divide, you have to see if I can factor either the top or the bottom. The numerator can't be factored, but this denominator can. Remember, you're finding two numbers that multiply to give you negative 2, but add to give you 1. And so those two numbers would be 2 and 1. And since we need a positive 1, the bigger number has to be positive. Now, if you notice, nothing can divide, so we leave it like this. Now, our domain. Well, we have to figure out, since there's a fraction, we have a denominator, we have to figure out what would make the denominator 0. So I'm going to set each one equal to 0 to see what we would have to exclude from our domain. So negative 2 and positive 1. So that means on the number line, we can't use negative 2 and we can't use 1. So when you write your domain, it'll be negative infinity to negative 2, union negative 2 to 1, union 1 to infinity. So that's how you exclude two numbers from your domain. Okay, I'll do one more example. And this example, both functions have square roots. So the first operation will be addition. And like I said before, you're going to try to combine like terms, but we may not be able to. So you're taking x minus 5, and you're going to add square root of 5 minus x. Well, there's nothing we can really do with this, so that's as far as we can go. Now, your domain, you have to figure out what domain would take care of both functions. So this is square roots. We got to find out. We have to keep our square root non-negative. So x minus 5 greater than or equal to 0, and 5 minus x greater than or equal to 0. So that means in this domain, my x's have to be greater than or equal to 5. In this domain, when I subtract 5, I am now dividing by a negative, which means this inequality has to flip. Okay? So whenever you divide by negative, that inequality has to flip. So in this domain, my x values have to be smaller than or equal to 5. So we have to figure out which of these domains can I use to keep both of my radicals non-negative. Okay, so the only way possible that we can do that is if our domain is just 5. Because we can't use negatives over here. We can't use numbers larger over here. So the only thing that we can both use for both, because they have this equal sign, is 5. So our domain, the only number we can use that would be safe is 5. Subtraction is similar. And the only difference is we have a subtraction sign between them. And it just looks similar like that. And we've already found the domain for these two radicals. So it's the same. The only safe number we can use without breaking the rule is 5. Multiplication. This must be a parentheses. We have square root of x minus 5 times 5 minus x. And we really can't multiply that. So we have to leave it like that. And our domain, remember the only safe number is 5. And then my division, or dividing, I'm going to put the F on top and the G in the denominator. Okay, and that's as far as you can go. This domain is breaking both of our rules. We have a square root and we're dividing. Now, if you notice on all the other problems or examples above, 5 was our domain because that was the only safe number. But since 5 would make our denominator 0, we can't use it, which means our domain, we can't use any number. So the domain would be no, and we usually use that symbol for no solution, but that means the empty set, which means no number is safe. So we can't use any numbers in this particular example or any values of x. And that is it.